The passage of a black hole near the solar system triggered the final countdown to a global catastrophe that destroyed almost all the planets of the solar system. Only Earth survived, and even its survival came at a very high cost. But why was the catastrophe ahead if the black hole had already gone? Exactly how much time did civilizations have to prepare for the end of the world? We will try to find answers to this and other questions in this series. You are watching the Epoch of Distrust channel with Mikhail Kamikov. Over the past few episodes, we have been modeling asteroid and comet collisions with Mercury, Venus, the Moon, and Earth with you. We calculated the consequences. We found out that meteor streams are traces of cosmic collisions in Earth's orbit. We even found 18 comets and proved that they are all remnants of one large object that exploded right in Earth's orbit. We see gigantic scars on the surface of the Earth. We see the Moon literally battered by a meteor storm from all sides. We see Mercury, not much different from the Moon in terms of size and degree of battering. We see Venus, Earth's sister, who wasn't as lucky as us. Its surface has turned into an unbearable, scattered hell. We see Mars orbiting, which are not even satellites, two fragments from a more massive body. And where's the body itself? Unknown. But the shrine left by him on the surface of Mars speaks of his size, comparable to the planet. We see the asteroid belt between Mars and Jupiter. We are tormented by the question of how this belt appeared. Official sources lean towards the idea that Jupiter's gravity did not allow a planet to form in this place. Among the alternatives is another theory about the planet Phaeton, torn apart by either war or collision with an asteroid. Whatever the case, the presence of the asteroid belt is a real mystery. And what's beyond the belt? Do we see traces of mass bombings there? But further on, the gas giants begin. Jupiter, Saturn. Beyond them are the icy giants Uranus and Neptune. How can one see the traces of their bombardments? After all, no crater will remain on a gas giant. Nevertheless, one can still see traces there. The main thing, as before, is to adhere to the rules of the solar system creation. Remember, all planets should have formed on one plane of the ecliptic. The so-called inner planets, Mercury, Venus, Earth, and Mars, have a fairly small mass. Yes, they are also located close to the main attraction of the solar system, the Sun itself. So they didn't manage to form satellites. The Moon is an exception and it formed differently. I have a separate video about this. But the situation is different for gas giants. Initially, they moved in a much larger circle, and therefore during the formation of the system, they swallowed up much more matter, and therefore their mass is much larger. In addition, the influence of the Sun at such a distance is much less. The gravity of these planets is much greater and extends much further. And that means they are capable of forming their own satellites by the same principle as the Sun. But the rules of formation are the same. And that means all satellites must be located on the same plane, coinciding with the general plane of the ecliptic. Correct, it seems so. And indeed, the classic Galilean satellites of Jupiter are arranged exactly like that. These are the closest to Jupiter and the largest satellites: Io, Europa, Ganymede, and Callisto. Even the smallest of them, Europa, is not much smaller than our Moon, and all the others are even larger. In light of this, let's take a small detour to answer a question that's just begging to be asked. How so? You yourself convincingly proved some time ago in one of the videos that there can't be 3 moons around the Earth in principle. And here we see 4 satellites at once even larger than the Moon. Yes, friends, this is no mistake. Earth cannot have 3 satellites the size of the Moon. Well, at least because they will all be forced to fit on a small patch about 400 kilometers from Earth, no more. If the satellite moves further away, it will simply break free from Earth's gravitational field. And if closer, all moons except one will be thrown out by the gravitational forces of the Earth and the Moon. But in the case of Jupiter, everything is quite different. Its gravitational ring, the area in which it is the full-fledged master of its satellites, extends for many millions of kilometers. And the 4 Galilean satellites live freely in this space. They hardly interfere with each other. The first 2 are separated from each other by a distance of about 25,000 kilometers. The third one is already 400,000 kilometers away. And the fourth one is almost 800,000 kilometers away from the previous one. In addition, they move around Jupiter 7 to 8 times faster than our Moon. And that means they fix their position much more reliably. Yes, and their orbit is practically perfectly round. This speaks to the natural formation of satellites from the time of the protoplanetary disk, unlike our Moon, whose orbit is not at all ideal, no matter how some scientists would like to convince us. The lunar orbit is stretched by as much as 11%, whereas the deviation of Jupiter's satellites from the ideal circle is just a fraction of a percent. Another interesting point related to the Galilean satellites is their discovery. They were all discovered at once straight in one night from 7 to 8 January of 1610 by Galileo Galilei. Why actually did they get the name Galilean? So all these satellites have signs of formation from the time of the protoplanetary disk. However, something seems off. First, they are all synchronized with Jupiter. This means that they are always facing Jupiter with only one side. Yes, it turns out our Moon is not unique in this respect. Space is full of such synchronized planets. But how is that possible? In the video about the Moon, I explained that it's synchronized with the Earth due to the orbital bombardment of asteroids from one side, which melted it and made it more susceptible to tidal forces. So, there should also be similar traces of bombardment on Jupiter's Galilean satellites. Let's take a look. Io is the closest satellite to Jupiter. Craters on it are not particularly visible. And it's not surprising because it's the most volcanically active object in the solar system. It's practically all made up of volcanoes, more than 400 of which are constantly active, ejecting huge masses of lava into space. The size of the lava flows reaches 500 kilometers and more, which is a lot for a satellite with a diameter just over 3,000 kilometers. In fact, Io hardly ever rests. This explains why it is turned on one side. However, it doesn't explain how it could have formed in the first place. If Jupiter's gravity doesn't let it settle and ejects material, then how could Io have formed at all? However, our previous calculations made in the Mars video suggest that Jupiter's mass should be 4 whole and 5/10 times less. Yet it is still colossal and capable of holding and forming all these satellites, but it will not tear them apart with tidal forces. This is an argument in favor of the idea that at some point Jupiter swallowed too much excess mass, increased in size, and began to devour its own satellites. That is, there were collisions, and very many of them, Let's look at the next satellite, Europa, but here too, we won't be able to see the crater. The whole satellite is covered with ice. Moreover, scientists suggest that under the ice hides an entire ocean of water several kilometers deep. There is no consensus on whether this ocean is made of liquid water or semi-liquid convective ice. Some scientists even suspect the presence of life in this ocean. And on the surface of Europa there is a very thin but still atmosphere, moreover it's oxygen. However, no matter what, now we are only interested in two moments. Firstly, the ice by definition does not give us the opportunity to see a multitude of craters. They will be very quickly hidden by the freezing water. However, despite this, there are still about 40 craters. Apparently, left by very small meteorites, possessing too little mass and speed to penetrate the ice or heat a large space around the impact site. And secondly, what? Water ocean? Seriously? But this satellite is smaller than the moon and it has a multi-kilometer ocean? Well then, where's the lunar ocean? After all, from the official point of view, the moon formed simultaneously with the Earth and is actually a piece that broke off from it. So the materials from which the moon formed should be exactly the same and in the same proportions. Then where are the lunar oceans, the lunar atmosphere? Any answer about evaporation or escape is shattered by the fact of the existence of an ocean and a strongly eroded atmosphere on Europa. So there can be only one answer. The moon is not part of the Earth and was formed later and under different conditions. More about this in the video Moon. But we digress. The next satellite of Jupiter is Ganymede. It's almost twice the size of Europe in terms of dimensions. But just like Europa, its surface is made of ice, beneath which again is a multi-kilometer liquid ocean. However, the traces of asteroid bombardments are very clearly visible on it. And considering the fact that almost the entire surface is made of ice, such traces and craters should fairly quickly be smoothed out and leveled. There can be no talk of millions of years after the impact. That is, all the craters are relatively fresh. But the most surprising thing is in something else. This satellite has its own magnetic field, which on the one hand gave birth to the hypothesis of a liquid metallic core similar to Earth's, and on the other hand, this satellite is always facing Jupiter with only one side. That is, it is synchronized. It's strange that under such conditions the core's convection occurs, generating a magnetic field. Mars, for example, is larger than Ganymede in size. However, it has no ocean and a single magnetic field is simply absent, as if all the processes in the core have stopped. But this is also a topic for a separate video. The main thing for us is that there are many fresh craters on Ganymede. Almost a third of its surface is covered with them. Let's move on. The last of the Galilean satellites is Callisto. It's slightly smaller than Ganymede, but still practically identical in size to Mercury. However, no magnetic field is observed here anymore. However, a huge number of impact craters are observed. We found what we were looking for. A huge number of craters and bombing traces. The subject of Jupiter's Galilean moons is vast. It's full of mysteries and puzzles, so we won't dwell on them for long now. I also won't say anything yet about the other 75 satellites because that's such a broad and interesting topic that it will have its own separate video. The same goes for Saturn. 6 of its closest and largest satellites are simply scarred by traces of collisions with asteroids and meteorites. Mimas, Enceladus, Tethys, Dioneira, all except for the largest satellite, Titan. But with Titan we simply can't see the surface because of the opaque dense atmosphere. By the way, I can't resist the pleasure of showing you a photo of Mimas, one of Saturn's satellites. This is who the Death Star is actually modeled after in the Star Wars films, not the moon at all. We will also leave the other 76 satellites of Saturn unnoticed for the same reasons, and move on to Uranus, and again we will only look at the largest satellites. Miranda, Ariel, Umbriel, Titania, Oberon. They are all covered with traces of collisions. In fact, we found what we were looking for. Specifically, confirmation that absolutely all planets in the solar system are covered with traces of literal bombardment by large and small asteroids and meteorites. By this point, most viewers probably have a burning question. Why are you showing us these obvious things? And we've known this almost since kindergarten. Watch any movie about space, play any space game, read any science fiction story. All the satellites are always completely in the craters there. What's unusual here? Just one thing. The probability of an asteroid colliding with any planet, let alone a satellite, is negligible. Even a probability of 1 in 64,000 is considered very high by us. And in the overwhelming majority of cases, the probability of collision is estimated as 1 in 400 million or even higher. Nevertheless, we see the traces of mass bombings right before our eyes. What traces? Tons of small meteors fall on Earth every year. Just the Chelyabinsk one alone is worth it. And last summer in Turkey? Just a meteor shower. Well, okay, let's admit those meteors like Chelyabinsk or Tunguska have a different explanation. Watch the previous episodes. But that insane amount of asteroids that fell on the Moon, Mercury, Venus, Mars, Jupiter, and so on, where did they come from? Even the chance of colliding with one asteroid is estimated as 1 in tens of millions. The only thing that can come to mind of a normal scientist is to multiply the number of craters by the number of chances and ultimately stretch the evolution of the solar system over 4.5 billion years. Well, to make everything fit. In addition, at the subconscious level, the stereotype is laid that craters are immutable. They are always and everywhere. Because otherwise, such a number of impact craters per square meter of the solar system is simply inexplicable. Yes, in previous episodes I showed how meteor streams appeared, how strikes on Mercury could trigger strikes on Venus, showed that some comets clearly originated after catastrophic explosions in Earth's orbit, and so on. But each time for this or that case, I took already prepared data or modeled collisions specially, calculating a guaranteed collision in advance. But even at the modeling stage, when everything seems to be in my hands, it was quite difficult to hit the asteroids on the planet from a great distance. I had to calculate and adjust the speeds of their orbits. But how the meteorites ended up in the right point in space, I still haven't explained. I didn't explain precisely because the chance of being in the right place at the right time is almost zero. And this is even in the modern solar system. And in the one that just formed from the protoplanetary disk, where all the planets, satellites, asteroids occupy strictly their place and trajectory, close to circular, it's absolutely impossible. However, the fact remains a fact. There are unimaginably many meteorite craters in the solar system, and therefore scientists stretch their appearance to billions of years. And those who disagree with them blame everything on other civilizations, interplanetary war, some kind of flinging stones at each other. But there is a third explanation. In the last episode, I showed what changes a flyby of even a small black hole not far from the solar system can cause. Its gravity will inevitably shift all the planets off their orbits. Some more strongly, some less so. In the process, the flatness of the ecliptic of all planets will change, and consequently, the tilt angle of the axis will automatically adjust. It's quite likely that it will rip some planets from the solar system and swallow them whole. But not necessarily. And some objects will simply transition to a new orbit and continue their journey through the universe with it. And some planets will be torn apart, having ended up between two fires between a black hole and the sun. However it may be, we are interested in those objects that did not go with it, but remained. And a lot has been left, at least the entire Kuiper belt. It's a vast space beyond Neptune's orbit, about 20 to 30 astronomical units wide. That is approximately 4 billion kilometers, filled with asteroids and comets. And they all also formed from the protoplanetary disk, but apparently did not combine into a single planet due to the huge distances between them. Many of the planets that never formed, for example, Pluto, Haumea, Makemake, Eris. This is the belt that should have been hit first and foremost by our black hole. That part that was closest to the hole was undoubtedly captured by it. Everything that was in this sector was doomed. However, the Kuiper belt is huge. If one sector is swallowed by a black hole, the opposite one probably didn't even notice it. But it's the two side sectors that interest us the most, because the black hole didn't manage to swallow them, but it greatly affected the speed of many of them. It increased the speed of some, while it greatly slowed down others. Some asteroids were simply torn apart, caught between the gravity of the sun and the hole. By the way, a classic example of such an asteroid is the planetoid Oumuamua. At its maximum diameter, it reaches 2,300 kilometers. He is one of the survivors. It is notable for the fact that its shape is not completely spherical, but rather resembles a disk, as if someone had squashed a sphere. Astronomers blame its high rotation speed around its axis for everything. Days on it last just under 4 hours. It sounds reasonable, but it doesn't explain what exactly spun it up to such a speed. But the opposition of two gravitational fields, the solar and the black holes, could well have spun up the object and stretched it and torn it apart. In addition, there is another planetoid there, Makemake, which is quite comparable in size to Haumea and even spins almost as fast, about 7 hours. But there is no elongation on it. Well, since speed is the main factor affecting the orbit, let's see what will happen to the meteorite in the Kuiper belt if it suddenly stops. In an ideal system, all objects in the Kuiper belt should move around the sun in a correct circular orbit. In this case, their speed will be from 3.5 to 4.5 kilometers per second, and their year, that is, a full rotation around the sun, will last from 250 to 550 years. After the departure of the black hole, the speed of many asteroids in a certain zone of its action must have inevitably slowed down due to its gravitational influence, which in itself, after the departure of the hole, affected their orbits, more precisely on their eccentricities. The orbits became more elongated and their perihelion accordingly went deep into the solar system. And depending on the degree of braking, their perihelion was getting closer and closer to the sun. Each of the break it or stopped asteroids is now heading towards the main center of attraction in the system, the sun. A powerful stream of thousands, hundreds of thousands, maybe even millions of large and small bodies of whole asteroids and fragments of torn planetoids of all sizes flying towards the center of the system. This stream was the advancing apocalypse. But to cover the distance from the borders of the solar system to the sun, it needed time. Let's check on the simulator how much time exactly the past civilizations had to prepare. We take a regular asteroid or comet, place it at a distance of 50 astronomical units from the sun. We set it to 0 speed and see what happens. As expected, the Sun begins to gradually attract it, and the absence of lateral impulse directs our projectile straight through the entire system to its center. At first very weakly, but then gaining more and more speed, our asteroid begins its journey. And approximately 65 to 70 years later, it ends its journey crashing into the Sun at a speed of about 600 kilometers per second. But if it had even a slight sideways impulse, then the perihelion of the orbit would have shifted relative to our star. The first hit of such a stream was undoubtedly the most powerful and dense. The following ones were already weaker. Part of the comet evaporated, part of the asteroids or semi-planets were torn apart by the Sun's gravity. If the black hole hadn't done the same thing before, and now an asteroid tsunami began to roll around the solar system, to blow up whole planets, to bombard the Sun, Mercury, Venus, Earth, Jupiter, and all the other planets. But the first hit, as we now know, should have come to the planets about 60 years after the departure of the Black Mountain. And then a whole cycle of catastrophes fell on the system, with a periodicity of about 120 years. This is simply the period of rotation of the stream along its orbit. And with each year, this stream became weaker, and the border of its arrivals more and more blurred. But that's a topic for other videos. The old version sounds wild and fantastic, but if it's at least partially true, there should be traces in Kuiper's belt from the passage of an object with strong gravity. Of course, we won't see the number of asteroids that should have been there originally, but what we should definitely see is a torn piece from the evenly distributed field of asteroids, the part that was closest to the hole and was simply swallowed by it. Well then, let's look at the real scheme of objects of the Kuiper belt, according to the data of the National Aeronautics and Space Administration Small Planet Center. The asteroids of the main asteroid belt are marked in green. And here is the sought-after gap. That sector in the belt, the object from which the black hole devoured.